our company will present an integrated design project. We are Metech Group, a team of 5 members. There are Maureen, Marilyn, Nurushamimi, Julian, and myself, Bevila. Before diving into specifics, let's start an introduction to Sungai Maro Agri-Farm, which has experienced some key aspects of our works. The Sungai Maro Agri-Farm is a small-scale agricultural project located in Sarawak, Malaysia. It is a bright innovative practice such as the rain shelter. Rain shelter is a solution to control excess rainfall and water lodging on the crops. The feature of the farm is the crop rotation. They're planting different crops. The farm faces 2 challenges. Firstly, harvesting heavy raw melon, which require manually handling. The heavy weight manually handling time-consuming and physically demanding. The second challenge is pesticide. The farm uses the automated and manually pesticide method, each with limitations such as water wastage and complicated spraying activity.
For our product design concept, that is ZipCart, the system which is designed to simplify harvesting and pesticide application, which is powered by DC motor. It runs on cable for smooth and semi-automated operation. The cart features adjustable height and easy to remove basket for loading, and sensor to ensure efficient performance. Our ZipCart design is to improve working condition and productivity at Sungai Marong, meeting the client needs in a safe and cost-effective way. Let's take a look overview animation of our product functionality. To adjust the height, remove the bolt and nut from the square hollow steel pole and slide the height adjuster to the desired position ranging from 1.1 meter to 1.4 meter. To remove the basket, detach the key pins on both sides of the frame. This allows the polypropylene basket capable of holding up to 23 rock melons or maximum weight of 57.5 kg to be removed for the convenient loading and unloading. To remove the 5-liter water capacity tank, first detach the pipe and connector between the pump and tank. Then, slide the tank out from the opposite side of the frame, and once refilled, slide the tank back into position, reattach the pipe and secure the connector, ensuring the system is ready for pesticide spraying. After completing the necessary adjustment based on preference, reinstall the height adjuster, sliding it into position and securing it with the removable bolts and nuts. The cart moves along a zinc galvanized steel cable powered by a 25-volt DC motor with a cable tensioner ensuring proper tension. This ensures smooth movement during harvesting and spraying. The inductive proximity sensor can be moved vertically or horizontally to ensure optimal detection, distance, or angle based on user preference. The system is operated using 3 simple buttons, one for harvesting, one for pesticide spraying, and a stop button to release the motor, brake, or stop the operation.
Now, we'll proceed with the material that we've applied in our products. ZipCart, which has 4 main components that are poles, cables, ZipCart frame, and zipline pulley. For poles, we selected steel ASTM A36 with thickness of 3 mm, height of 2 mm, and width of 2 by 2 inches. For cables, we've selected zinc galvanized steel, whereby the main cable size and the motor cable size is 8 mm. For ZipCart frame, we've used steel ASTM A36 with thickness of 3 mm, and the weight of the basket frame is 13 kg, while pesticide tank frame is 7 kg. And lastly, for the zipline pulley, we've selected the stainless steel, which can carry load up to 15 kN. Next, we will demonstrate the operation procedure for harvesting. First, Make sure the zip cut is at the collection point. And second, press the basket into the zip cut frame and close the lid. Then, turn on the system power and push the harvesting button. And start filling the basket. The motor will stop automatically after it reaches the collection point. After finish, open the lid and take out the filled basket. And close the lid. Now, we will demonstrate the operation procedure for pesticide control. First, we need to make sure to fill up the pesticide mixture into the tank beforehand and make sure the zip cut is at the collection point. Now, turn on the system power and turn on the pesticide pump. Pesticide pump will delay after turn on and then push the pesticide button. Let the pesticide spray along the crops. By design, the nozzle of the pesticide consists of two different angles. The top nozzle is 70 degree while the bottom is 30 degree angle. Both nozzle is 0.8 mm. The purpose of the different angle is to make sure the spray angle of 40 degree and spray trajectory will be able to cover a plant at a distance of 30 to 35 cm and a height of 1 meter above the ground.
In mechatronic, these are the list of components that is available in the system. First one will be the microcontroller, and the microcontroller that we will use is Arduino Uno to control the sensor and the DC motor by using C++ coding as the communication. The actuator is the DC motor, and last one is the sensor. Sensor that we will use is the proximity sensor. This is the system circuit. We use Tinkercad as the simulate circuit for our system. There is slightly different in the Tinkercad components. For example, the ultrasonic sensor will be the proximity sensor since there is no proximity sensor in the Tinkercad.
This is the economic analysis for our design. The selling price per unit is 1,960 ringgit. For the production process to break even, 442 units of product would need to be produced to gain profit and to cover the total revenue. Thus, the break-even value is 865,940 ringgit. Our bid cost ratio is 1.43, which exceeds 1. This suggests that economic gains surpass the cost of investment, underscoring economic sustainability and indicating potential growth for the project. This is the rules, regulation, guideline, and policy related with our work. First, Occupational Safety and Health Act 1994. Second, Pesticide Act 1974. Third, Factories and Machinery Act 1967. Last but not least, Environmental Quality Act 1974. At Metech Corps, we believe in creating a positive impact beyond our bottom line. These are the several UN Sustainable Development Goals related with our work. First is SDG 2, second is SDG 8, third is SDG 12, fourth is SDG 13, fifth is SDG 15.